Okay. So last class, guys, we talked about the hips and valleys. So I want to go back through that again. So let's start out looking at hips. And we're going to go over several different cases. Is there anybody that got all the homework done and just wants the answers for it? I had to ask. Just in case, you know. So this is a 36-foot span. And we're going to give this a 712 slope. I want to find that jack rafter decrease. I want to find the hip corner, the hip rafter itself, and the jack rafter decrease. So now this is 712. This is conventional, so that means the slope is 712 on all of the sloped surfaces. Now, do you guys recall what step 1 is? We're going to analyze the common rafter. So to analyze the common rafter, what do we know about it? It's a 712 slope, 36-foot span. So now what can we figure out? Well, there's certain things we have to figure out. The important part to us, true guys, the important part to us is the length of the common rafter over here. But in order to find that, we first must know the height. To find the height, we need to know what? Well, we've got the slope, the 712, but before we can use that, we need to know the run, which is half of the span of 36, which is 18 feet. So now we use the slope of 712 equals, where does the 18 go? 18 goes on bottom. It's a run. The 12 is the run. So 18 goes there. And we will cross multiply. 7 times 18 divided by 12 is 10.5. So 10.5 feet is our height. Now then, to get the length of the common rafter, it is the square root of, it's the square root of 18 squared plus 10.5 squared. So, use 20.839 feet.
Can we just round to 100?
We're going to 3 decimal places. So this common rafter is 20.839 feet. What else does that tell us? Step 2 is to find what? The longest jack rafter. Well, since this is a conventional case, that longest jack rafter is the same as the common. 20.839 feet. Now at this point, I'm going to add in a step in here that we didn't do before, and that's going to be to find the hip rafter. The hip rafter is just this right here. How do I find that length? Well, it'll be the square root of 20.839 squared plus 18 squared. This distance right here is going to be half the span, or 18 feet. So 27.536. That is the length of the hip rafter, that rafter that goes up the corner. Sometimes called the hip master. Now, step 4 was to find the next longest jack. How did I do that? Well, I use triangles here. This is 18. This is the 20.839. My next triangle comes from exactly right here. So this is going to be 2 feet less, or 16 feet. And this is going to be x. So what's my proportion going to look like? 18 over 16 equals 20.839 over x. So now we cross multiply and divide. 20.839 times 16 divided by 18. 18.524 feet. And of course, the final step is to find the decrease. So 20.839 minus 18.524, 2.315, which we can convert to 2 feet. 0.315 times 12, 3 inches, subtract 3, and times 16 is 12.48, which is 12/16 or 3/4. Questions, comments, complaints? Please, for mercy. Test?
No.
Want one?
No.
We can do a quiz.
No.
Let's take a look at how these problems would work if we have different information given to us. What if I tell you that it is a conventional hip and I tell you that the run of the common is 16 feet. And the slope, now I don't have to specify slope of common because the slope of the common and the slope of the hip are going to be the same. It says you specify the slope is, let's do 612. And I still want to find that jack decrease. Well, this is really can be equated to what we've already done. What's the span over here going to be? Not 16, 32. Because the run of the common is just half the span, right? Of course, we got 612 slope. Well, now this is exactly like what we did before. Step 1, we're going to look at the common rafter. We have a 612 slope, 32-foot span. Looking for the height, we were given the run was 16, so it's still half the 32. To find height, what are we going to do? 6 over 12 equals h over 16. Tells us that h is 8 feet. For length of the common, square root of 8 squared plus 16 squared is 17.889 feet. Make sense? I'm going to give you guys a couple minutes, try to take that the rest of the way. From what I found there, now try to find the jack rafter decrease. Okay, so we know that the longest jack here is going to be the same as the common, 17.889, and it is on a 16-foot space here. So when we do the next one, it's going to be at 14 foot. So we're going to draw 16, 17.889, 14, and x. 16 to 14 equals 17.889 over x. And cross multiply and divide. Oops. 17.889 times 14 divided by 16. 15.653. Okay, as long as it works. I mean, you could have 16 over 17.889 equals 14 over x. That works too. So that means our decrease, 17.889 minus 15.653, 2.236. And I'm going to assume you guys can handle changing that to feet, inches, and 16, so I'm not going to do it here. So, next, let's take a look at what happens if I tell you it is conventional still. I tell you that the run of the common is 16 feet, and the length of the common is 20 feet. Well, again, let's go back to our standard picture here. The run of the common being 16 feet, of course, means that this is 16 feet, which means, of course, that our span is 32 feet. What we are missing is the slope. But we don't really need the slope because what we're given is this. If this is 16 feet, of course, this is a 32-foot span, we're already given that this is 20 foot is the run of the common. That was the thing that we needed. The whole point of having the slope was so we could figure that out. Once we know that that's 20, we don't care about the slope. So this is 20 feet here. Now then, to find the next jack, well, this is going to be really simple. This is 16, this is 20. This next one's going to be at 14. And x. So it's simply 16 over 14 equals 20 over x. So 14 times 20 divided by 16 is 17.5. So that our jack rafter decrease, 20 minus 17.5 is 2.5 feet. I'll even be nice and convert that to 2 feet 6 inches for you. Yeah, that's kind of me. Okay. Back to the valleys now. Remember, our valleys, we're dealing with a main roof and some sort of an L coming off of it. And in the conventional case, what we're looking at is the valley and the main having the same slope. Pretend this ridge goes right down the center there. It's a little off. We're looking at the valley and the L, or the main roof and the L having the same slope as a conventional case. So we don't really care about the span of the main roof. It can be whatever. Let's say it's 40 feet here. It doesn't affect us. What we're concerned about is the span of the L. Let's say this is 28 feet. Let's say that our slope here is 10, 12. Actually, you know what? I'm going to change that for just a second. Just because I can. Just because I want to show you something. First example is a 712, so I'm going to make this slope a 712 as well. So what we're looking at now is not the common on the main roof, but we're looking at starting out with the common on the L. We know that's a 28-foot span and a 712 slope. What do we do from there? Run is 14, so h is 7 over 12 equals h over 14. So 7 times 14 is 98, divided by 12 is 8.167. 1667. 8.167, we call it, feet. Then, of course, we need the common rafter length. It'll be the square root of 8.167 squared plus 14 squared. Gives us 16.208. So that is the length of our common on the L. 16.208 feet. Now here's the key. How do we know this distance here? It's 14 feet. Where'd that come from? Half of this span here. It's the run of the common. So then our next one we're looking at is going to be here at 12 feet, right? So we've got one triangle here. 16.208 at 14 feet. And the next triangle will be at 12 feet and x. So our proportion, 14 goes to 12 as 16.208 goes to x. So times 12 divided by 14. 13.892. So our decrease, 16.208 minus 13.892 is 2.316. Sound correct? Not always in the 2s. Sometimes it can be up in the 4s. But I want to show you this first example we did. This was a 7/12 slope. We got 2.315. It's just round off here. It's 2.316, 2.315. If it's a conventional hip or conventional valley, if it's a 7/12 slope, the decrease will be the same. So 2.31, 2 foot 3 3/4 inches on a hip. The decrease on a 7/12 conventional valley will also be 2 foot 3 3/4 inches. Does that make any sense? Yes? No? Don't want to play anymore?
Todd, can you scroll up just a tiny bit? Okay, so you know how we have 14 here?
Yep.
And we have 14 as not the span, but
the run, yep.
Are these two
always the same if it's a conventional valley?
It's conventional.
If they're the same slopes, yes.
Okay, so that's always going to be the case.
Exactly.
Okay. I remember something being mentioned like
Yep. As long as it's conventional, that'll be the same. If it's not conventional, then it opens up a whole new can of worms. So now what we're going to do is we're going to explore. I'm going to save this recording.